So welcome to our WAPOR webinar. Our topic this week, so we are delighted to see that we've been able to have so many people join us, and we hope that many others of you will be able to see this in the recorded version. One of the things that we're really proud of at WAPOR is that our webinars are designed to help and inform and are free and available to anyone who's interested. So we're very delighted that you're able to be here. I'm joined today and really honored to be joined by Dana Thomson and Dale Rhoda, who are experts in gridded population sampling. Dana is the Associate Director of the Science Application Division at CSUN at Columbia University, and Dale is a statistician. And they are the editors of this wonderful handbook that I encourage you all to look at, designing and implementing gridded population surveys. These are really, I find, one of the most fascinating and interesting developments in sampling that I've seen. And Dale and Dana and Dale are going to give us sort of a brief overview of this, and then we will be open for lots of questions. So we encourage you to be thinking actively and popping things in chat, or you're welcome to ask questions on screen. We just are delighted to have so many people here. So Dana and Dale.
Brilliant. Thank you so much for that introduction, Chase, and for the invitation to speak here. It really is an honor to be with this WAPOR community. As said, this is a manual that Dale and I published just about a year ago on gridded population sampling. And as far as we know, it's the first and only kind of authoritative manual on what is available in terms of data sets and tools to perform this kind of sampling. And also, as Chase mentioned, this is probably the biggest innovation in defining a new era of sampling in lower and middle income countries where you might have outdated censuses or censuses that are contested, and we don't have a very good grasp of the population. So I don't have enough time to go through all the details of the manual, but you will find throughout, even on the front page here, gridpopsurvey.com. You're welcome to check out that link while we go through. My goal here is to give a brief overview of this manual and what is gridded population sampling, who's using it for what, when is it appropriate or not appropriate, and the basic tools that are available. And a little shout out in case you want to get involved with some further development, research and development in this field. But my hope is that you will go to the manual, download it and check it out for yourself and maybe apply it in some of your own work. So I'm going to briefly just give an overview of the typical survey workflow in low and middle income countries. I know this is going to be old news for many of you, but just to orient us to what kind of survey we're talking about. We're talking about face-to-face surveys where we might stratify by subnational region, then in each stratum choose an independent sample of, say, enumeration areas, and these will be our primary sampling units. We might oversample in a place that is a majority rural context. We might oversample in urban spaces. Then we're going to go start field work. We're going to go out. We're going to usually hand draw all the buildings in our primary sampling unit and any of the major roads and landmarks. We might need to segment if there was a lot of population growth since our last census and there's more people than we expected. And then we're going to do field work yet a second time by sending out, we're going to go out another time and list households. We might have to, in those segmented PSUs, and then we're going to sample households and then do our survey. So what is a gridded population survey and sampling? It's really just a typical household survey, but instead of census enumeration areas, we're deriving our population from a gridded population or modeled population estimate. And so these are three different ways we might take the same gridded population estimates, these little estimates of counts of people in tiny little grid cells, and transform them into a sample frame. One option is to sample directly from the gridded population estimates. They have a defined geographic boundary with an estimated population count. So on their own, they technically fit the definition of what a sampling unit might look like. However, this can be hugely challenging because our sampling units in this case will be uniform in area and shape, but they will vary widely in their populations. Sometimes people get around this by picking a grid cell size for urban populations and then another for rural, and just kind of deal with the varying amount of people in those different grid cell sizes. But more commonly in gridded population sampling is one of these two other options where we try to mimic an enumeration area by grouping grid cells into areas of approximately similar population total, where the area might differ from one to the next. So an example of doing that with the gridded cell boundaries themselves is a tool called GridEZ. I'll mention this a bit later in the presentation. Or we might use something like the last census as our boundaries, update it with our new population estimates, and possibly use roads, rivers, or other natural features to further segment. There is a tool that is expected to be released later this year called Pre-EA. It's a QGIS plugin that helps to do this process. But these are the ways that we turn a gridded population estimate into a survey sample frame. And from there on out, it's generally pretty much similar to a typical survey, census-based survey. But when we have these gridded boundaries, we sometimes use other tools. And so I'll be talking about what some of these tools look like. And so just to go back to an example to demonstrate where gridded population surveys and typical census-based surveys are similar and different, we can still stratify by subnational area. We have to create our sample frame from gridded population estimates. So there's 3 different ways that could look. Here's the example with multi-cell gridded units, where we sample with probability proportionate to size. We can optionally oversample urban areas still if we need. What we get is a sample that has a distribution that looks pretty much the same as a census-based survey, but you might end up with boundaries of sampling units that do not align with natural features in the real world, or what are known on the ground to be enumeration area boundaries. You can see this example here. It's a real world example in Rwanda, where the boundaries intersect buildings and roads, and might be a little bit challenging to navigate. And most people are really concerned about, if you've never done a gridded sample, how to deal with these buildings that are intersected. There's actually a really easy protocol that folks have done in the field, which is to pick, say, the north and east boundary, like the top and right side boundary, and always include a building when it's intersected on those edges. And then a west and south boundary, you always exclude the building. So the building always belongs to only one PSU. But in terms of navigating this awkward shape in the real world, it does require a little bit more planning. Maybe the use of satellite imagery for your field maps, so that people either on a tablet can identify themselves within the boundary or geofence themselves, or on the ground, just use a paper printout, or both. But you do end up with gridded PSU boundaries with specific populations and a maximum area if you use a tool like GridEZ, which is done in a lot of surveys these days. And then the field work looks really similar to what you would expect from a typical survey, but here's the introduction where you might look at OpenStreetMap or some other existing building footprint data set first, just to make sure that what you're seeing in satellite imagery in the sampling units that you're going to, you may have a sense of where the buildings are before you go to the field, so that you don't have to draw maps when you get there. You can use that time more efficiently to actually list households. And here's an example from a survey that was done in Nepal a few years ago, where we were really evaluating the accuracy and feasibility of gridded population surveys in Kathmandu, Nepal. We found it extremely useful. It performed as good, if not better, than a typical household survey. And we used these tools, OpenStreetMap. We had printed paper maps. We also had digital maps. The same map was also available on our tablets, and we were able to do the listing electronically. And then that pre-populated our our questionnaires when our interviewers went back to the field. So start tracking your questions if you want to hear more about that example. You might be wondering about where to get these gridded population data sets. This is the landscape as of today of which data sets are kind of available off the shelf. There's 9 global gridded population data sets that are generally available in most of the countries that we'll be working in, lower and middle income countries I'm talking about. But you'll notice all these maps are zoomed to the same exact area. It's a small area, downtown Lagos, Nigeria, along the waterfront. And you will see a lot of variation in these maps. In the top left, you will see a few data sets that have very large grid cells. These are 1 by 1 kilometer. In the bottom right, you see a data set that actually has 30 by 30 meter cells, grid cells. That's about the size of a building. And then the bunch of data sets in the middle with about 100 by 100 meter grid cell units, and those are about the size of a city block. Generally, I would say that the top left is less accurate and the bottom right is more accurate in terms of producing gridded population estimates in units that are about the size of an enumeration area. There are a lot of caveats to this, and the reasons have to do with the modeling techniques themselves and the input data sets to these different gridded population products. So in the manual, I spend a lot of time in plain language describing the methodologies behind these different gridded population data sets and then make a recommendation for different types of settings. I would just recommend checking that out directly, but the overall message is less accurate top left, more accurate top right. And another takeaway here is that gridded population estimates are rapidly evolving type of data set because the availability of building footprint data in just the last few years has really changed the game in terms of how well we can estimate population densities and at what scale we can estimate those population densities. And so all of the bottom right data sets, all of them from Grid 3, World Pop Peanut Butter, Landscan, World Pop Constrain, Global Human Settlement Layer, Pop 2, and HRSL, all of these were produced in just the last 3 years. One of them, the GHS POP data set, was actually released just as we were going to print last year. So these are very hot off the press data sets. Generally speaking, any of these data sets would be a reasonable sample frame for most low and middle income country contexts. And I have warning symbols over this World Pop Unconstrained and Landscan Global. In fact, most gridded population data surveys to date have had to rely on one of those 2 data sets as a sample frame, basis of their sample frame. And all of those surveys were successful in the field, and many of them were evaluated for accuracy and feasibility, and they were fine. But those are not the most accurate data sets any longer at the scale of an enumeration area in most urban settings, especially. So please check out the manual if you want to learn more about gridded population data sets, how they're made, and when you might want to use them. I will say that in terms of what is the most important issue that will come up with gridded population sampling, it is the underlying accuracy of these data sets. That is the most important issue in terms of having a good sample. So who's been doing gridded population sampling? A couple years ago, in late 2019, Dale and I did a review of the literature, scientific literature, and the kind of gray literature and the network of people that we know doing gridded population surveys, and just did a simple count of who's doing gridded population surveys in lower and middle income countries. And feel free to check out the paper that came out in early 2020. At that time, we found that most surveys using this technique were opinion polls, which is why we're here at WayPoor and other opinion poll community events. But there are some other practitioners who are using this approach in program evaluation or just plain research, evaluating the technique itself. We have seen a national government use this. Dale and I both supported the National Bureau of Statistics in Nigeria to do a a large-scale survey using gridded population estimates. And groups like World Food Program have been using gridded population estimates in settings like the DR Congo, where the last census was in 1984, been using gridded population estimates in their work. So what's interesting is that many of the surveys that were captured in this assessment several years ago have continued every single year. And so at the time of this publication, there was almost 50 surveys that had been done globally with gridded population data sets as the underlying sample frame. And that number is probably close to 150 today because a lot of these surveys are done annually. So there are times when gridded population sampling is definitely not appropriate. I'm an advocate for this approach when appropriate. But if you're in a setting where there was a recent census and generally it's widely trusted, then that field reference population is going to be a much better sample frame than anything that's modeled. Modeled data set comes with model error, and it's often based on the last census. And you might be able to project those estimates and reallocate them in space based on features like building footprints, but you're always going to have a better estimate of the population if you've been to the field, and that's what a recent census gives you. So definitely use the recent census if it was done in, say, the last 5-7 years. When you start getting about 10 years old or even 7 years old, you start finding a lot of inaccuracies, especially in and around urban spaces. Another time to avoid gridded population sampling is if you have a very small coverage area. Again, these are modeled estimates. There's going to be more error at the finer geographic scale. And as you aggregate, if you aggregate grid cells into larger and larger areas, you kind of, you start to smooth out some of those errors. But if you have a really small coverage area, there's probably better techniques to derive a sample frame that might be field-based. And that would be preferable and more accurate than using a gridded population modeled estimate. And the last situation where I would not recommend gridded population sampling is if you are in a setting like Yemen or South Sudan, where there might be just lack of power and internet on a very regular basis. I would not use this approach because you almost always want to use some kind of map, like Google Earth at least, before you go to the field, just to check your sampling units and know where you're going, generate maps, etc. And all of those tools will require the internet to render satellite imagery. And so if your team doesn't have regular access, your planning team, your central survey planning team doesn't have regular, reliable internet, or if they're just not comfortable with basic mapping tools like Google Earth or Google Maps, this is probably not going to be a very useful technique. It's going to pose a lot of challenges. In most other situations, gridded population sampling is very likely a good option. If you have a grossly outdated or inaccurate census, we'll often find that the distribution of a gridded population data set, even if it's based on the outdated inaccurate census, the distribution of that new modeled estimate will be more accurate than the available outdated census. So it might not be perfect, but it will be the best available sampling frame. Also, if you are working in a dangerous area or a highly dynamic and complex area, for example, Kathmandu is a great example where there's just a lot of people moving in, there's a lot of seasonal migration. There are people living in very atypical housing arrangements because of housing crises. In those settings, you might be interested in doing a sample design that only requires one field visit, that the listing happens at the same time as the interviews. In these cases, gridded population data sets offer the ability to make much smaller area sampling units than you would normally be able to do with a census sample frame, because those little grid cells can be grouped into much smaller areas than a census enumeration unit. And that can allow you to do what we're calling area microcensus designs. They do go by other names. I've heard them, segment cluster sampling is another name I've heard used, where you interview everybody in a small area, maybe 10 or 15 households who are all neighbors. In a dangerous area, this is attractive because you can be in and out of the field in one visit, and you can still do a robust sample design versus, say, a random walk, where your sample weights are not calculated as robustly as many survey statisticians would like. And the same applies to highly dynamic complex settings. You might want to go to the field and have the same people do the listing and interviews. And that is because you will get a much more accurate picture from respondents about all of the atypical housing arrangements and the kind of hidden and vulnerable populations that might normally not get reported during a typical listing activity. So those would be the family that lives in a shack behind the durable structure. That might be the second and third families who are renting in the apartment and who are not listed on the contract. So all of those hidden populations often become, once an interviewer is speaking with a respondent, building that rapport, respondents are far more likely to report those kind of atypical households than they are to a listing team who's just walking around outside and asking how many people live here. And finally, if you are stratifying by areas that are not following administrative boundaries, for example, if you are you want to stratify on climatic zones or air quality bands or something like this, you inherently need a geographic sample frame so that you can classify who's in which strata, and gridded population data sets are inherently spatial. So they're an easy data set to use for estimating population by strata. I do want to make a quick shout out around this area microcensus design in terms of being able to accomplish two things at once that are very difficult to usually do in our world, is doing one field visit with robust sample weight calculations. The one stage or two stage area microcensus designs that we detail in the manual you are able to calculate these robust sample weights while only doing one visit to the field. And this is super attractive, even just as a cost saving and time saving measure. In the world of opinion polling, can help kind of get that turnaround that you often are looking for. So I'm going to feature one survey that the World Food Program did back in 2017 now, that I found very inspiring and is the basis for a bunch of these recommendations around area microcensus sampling. They did something which we are calling a two-stage area microcensus design. They had sampling units that were comprised of multiple grid cells that were approximately the size of a typical census unit, say 100 households. They decomposed the sampling unit into the underlying grid cells, and then they randomized the grid cells. And their field protocol was that the field team would go to the first cell, in this case, the red cell, interview all of the households that were eligible inside that small space. And they had a target of something like 15 households per cluster. And so if they had reached 15 households or exceeded that number, they would stop. But if they hadn't, they would go to the next cell that had been randomized, in this case, the orange cell, interview all the households. If they had met or exceeded their target of 15, they would stop. If not, they would go ahead to the next cell. And you could randomize all the cells. This was really clever because they're able to calculate sampling weights with the concept of segmentation, and but they only had to do one field visit, and they didn't have to deal with a huge variation in the number of households that they were getting per cluster or per primary sampling unit, which can be a challenge if you just do one stage area microcensus design. Like if you had predefined, say, 2 or 3 cells that you thought had 15 households, there will be some variation in that because there's model error. And so this approach really helped to manage the number of households responding per PSU, and also allowed robust sample weights and one visit to the field. So check out that design. If you are looking for tools to create a sample frame from these gridded population estimates, there's two that are kind of available off the shelf at the moment. The first one, GridEZ, is an R algorithm. The second one, which is called pre-EA, is going to give you it's going to give you boundaries that follow real features in the world, like major rivers or major roads, even administrative boundaries, but it does require a certain amount of GIS skills. You're going to use OpenStreetMap data to create boundaries, and you're going to group shapes that have population estimates into areas that are approximately the size of an enumeration area. There are some other tools, and I will quickly flash up a website. There's something called gridsample.org, but that you can use if you don't have any programming skills or any GIS skills. Unfortunately, GridSample will be going offline pretty soon, which is what we're hearing from the company that manages that tool. So just if you are doing a survey in the next month or something, you might be able to use gridsample.org as well to create your sample frame and not have to do GIS or programming. So now I'm just going to quickly summarize where we are with gridded population sampling, what the state of the field is, and also make a little a call to action for anybody who wants to get involved. First, I think it's worth saying that the tools for designing and implementing gridded population surveys are super piecemeal. You'll find in the manual that we basically say, okay, based on your sample design and the skill sets of your team, here's a series of tools that might be relevant, and here's how you can piece them together. That's the crux of our manual. We hope that you're able to do that. My vision for this field is that we have more integrated tools that make it possible to, develop a sample frame from gridded estimates and sample from it and go to the field a little bit more seamlessly, but we're not there yet. Gridded population data sets are evolving and improving very rapidly. So this is where it's important. Like I said, this is going to be the most important part of determining the accuracy of your survey, is how accurate is the underlying estimates that you're using. So definitely read through the chapter that describes existing data sets and pick one that makes sense for you, because not all estimates are the same. And we also have to be on top of this as a community of practice. And as we evaluate the accuracy of these estimates in the real world, is to find a way to report back, we actually enumerated 100 people in this area where we thought there would be 200 people, for example. And then finally, while this area microcensus designs, the 1-stage or 2-stage area microcensus designs that I've flagged are very promising, it is true that we don't have many examples of them being done in the real world. So if you are planning a survey and you need to have some estimate of the design effects of using this sample design, we don't have a strong evidence base at the moment. And so we really need to develop that. And we can do that with simulation studies. We can do that by reporting our results out from surveys that have used this design. And then the last thing I'll mention is where you can find tutorials on our website. So our website has a link to an overall manual, and then there's a separate section where you can filter and download a series of tutorials that are relevant for the tools that you're going to be using in your sample in the field. So the manual will help you figure out which tools you want to use, and then you can download tutorials that look like this. They're available as a Word document, which means that you can edit them and you can compile them into your own bespoke customized manual, which we hope will be very helpful to you. And you'll see each of these tutorials start with an example where you can follow through step by step, a real survey that has actually been done, or something that's based on a real survey that's actually happened in the real world using a gridded population tool. So that was my rapid introduction to our manual on designing and implementing gridded population surveys. At the moment, you can go to gridpopsurvey.com and download the manual yourself. My last plug will be to say that I've just started at Columbia University. So I've been only there for a few weeks, but what's wonderful about the role that I'm in now is that I work directly with all of the producers of gridded population data sets. So the World POPs, the Global Human Settlement Layer, the HRSL, all of those data producers are people that I'm interacting with. And I'd really like to work with those producers to actually generate sample frames so that we don't have to create them ourselves. We can just go and download a gridded population sample frame. That's what my goal is next. If that's something you'd like to work with me on as a practitioner, maybe in your country, please do reach out to me at this email down here, dana.r.thompson@gmail.com. And alternatively, you could reach out on Twitter, not Twitter, it's called X now. But that's it for me. Thank you so much.
Well, Dana, thank you very, very much. This is super fascinating and super interesting. For some of the folks here who maybe aren't quite as familiar with what a gridded population estimate is or how these estimates come about, it's not a census, it's model data. Sort of at a high level, what are the different ways that this population data can be put together?
Excellent question. I'm just going to go back to this slide. So there's two general approaches to gridded population modeling. One is called top-down, one is called bottom-up. Top-down modeling means that we're using an old census or something that's a full count of the population, and we're disaggregating it from, say, a district or county level down to a small little grid cell. So this is top-down. We have a count for everybody in the whole country, for example, and we're going to disaggregate it from the top. Bottom-up methods refer to any approach where we are not using an old census. Instead, we are predicting into area. We're going to do what basically an area microcensus. We're going to count population in a few small areas, and then we're going to predict into areas that we didn't count the population by building a model of spatial covariates, things like building footprints, land cover type, distance to major roads. And we're going to use those predictors to predict the population count in places that we didn't go out and count people. That's the two basic approaches. There's also different levels of modeling. Some of these data sets we call highly modeled, meaning that they're using a geostatistical model, which means that they also come with estimates of uncertainty. The model has uncertainty and usually has multiple inputs. There's a few of these where it's more of an algorithm that we say, disaggregate this county level estimate if you see this land cover type and this number of buildings, and this will be the count that you give to every cell. So HRSL is a good example where you see that all the cells in this area seem to have a similar population count. They probably do. All of those cells were given the same estimate. It was a simple algorithm that helped to disaggregate those counts. Whereas something like grid 3, this is a bottom-up estimate, but it's giving a different population estimate to every single cell. And something to just note, just because it's bottom up and not based on the last census doesn't make it more accurate. And just because it's what we call lightly modeled with a very simplistic algorithm doesn't mean that it's less accurate than a highly modeled geospatial data set. In fact, I've found that HRSL, which is top down based on old census data, and using what's called lightly modeled approaches, very simple models, no geospatial kind of model behind it with error estimates, often will give us more accurate estimates in places like slums. And the reason is this tiny grid cell size and their use of very good building footprint data. So spend some time in the manual checking out the pros and cons of these, but those are hopefully some language to give you a sense of how the models work.
Well, thank you so much. We have a question from Stas Kalinikov in the chat, but asking a little bit about the microcensus design and how this is similar to or different to an adaptive spatial design rather than a multi-stage design, and thinking in particular on some of the biological types of sampling, capture, recapture things that Stephen Thomson has worked on.
Dale, did you want to jump in on this one and say anything about the design work?
Sure. Stas is right. I think it's more of a comment than a question. And yes, it is an adaptive spatial design. Not you. We described it as multi-stage, where we are deciding whether to go on and collect data from an additional portion or not. But it could be more accurately described as an adaptive spatial design instead of multi-stage. But Stas is correct.
I wonder on the micro census, especially given how much of this is public opinion polling data. One of the things I always think about with, let's just say the classic field approach where we're trying to do multiple callbacks over different days is we're trying to minimize non-response and non-response bias. And I can see how in some places, we might have people who are away from their homes a lot, or who travel, or who work, or who do different things. And how do we account for those in that microcensus design? And sort of what are the risks of non-response bias or sort of controls to try to minimize that?
I can jump in a little bit here. The work that we did in Kathmandu, where we compared an area microcensus design with a typical two-stage design, meaning that we listed all households in a large area and sampled systematically from that listing, we found that the area microcensus design had a lot more diversity of household types. This was in a complex city, so as in Kathmandu, where there's lots of mixing. You know, there are segregated neighborhoods, but a lot of people are living in actually quite mixed social economic circumstances where if you live on the top floor of a building, you might be a higher income. And if you live on the bottom floor of that same building, you might be lower income. So there is a very different way that these kind of social stratification happens. But in that setting, we found that the area microcensus design actually exposed us to a lot more vulnerable households. And that doesn't necessarily speak to this question of callbacks, because I mean, I guess you could say you're in a smaller area, so the work to do your callbacks is maybe a little bit less. It would be the same for any sample design, but I just thought it was very important to note that the area microcensus design, despite what some of us might think that gives us more clustering of household type, that in complex urban areas can actually give us more diversity in household type. Dale, I'm not sure if you wanted to add anything around the callback question.
I was interpreting Chase's question as saying we're referring to it as a census, but we can only stay so long, and there may be some households where just the family's away for the duration of our time in that PSU or in that microcensus cell, and then so how would they be counted? Would we accept estimates from the next door neighbors of the number of noses that could press up against that window if people were home, or what would we do about households where we don't get any response during the census itself?
I would definitely record it as a non-response. I mean, you could go outside of your small sampling unit to find similar neighbors or something, but again, I think you have to know your context well, and you know, does it make sense to replace with a next door neighbor? Because in some urban contexts nowadays, it's not going to give you an interchangeable kind of household.
Right.
I see that Philip has had a hand up for a while. Did you want to ask a question, Philip?
Philippe? Are you Is that a question? Perhaps we can move to Timothy Van Barklum. We do encourage people to unmute and speak. Okay, here we have a question. It's actually, it came in the Q&A, multiple questions. Our main question is, what about margin of error and how is it calculated? I guess that's the first one. Second one is, how do you evaluate accuracy? And then we have a discussion about how this is used in Iraq. So thinking of Iraq, an example where we've studied these a lot, we have official estimates every 2 years based on 50,000 respondent surveys. The Office of Statistics does this to a very small PSU. Would that still be considered inaccurate? Maybe we can take these one at a time and think about the margin of error, how it's calculated, and evaluating accuracy.
There's the accuracy of the underlying gridded population data set, and then there's the accuracy of the sample itself. Accuracy of the underlying gridded population data set, I'll take first. That question has, the folks who are doing highly modeled, top-down modeling mostly, but any of the highly modeled data sets are often calculating errors, model error statistics as part of their process. And so they often will report that as well, which can be helpful to very technical survey folks, and is worth checking out. You'll see like the grid 3 data set comes with an uncertainty layer that has the same grid cells with an uncertainty value for each grid cell estimate. I honestly don't know how to use that. And I also find that the modeled error estimates are not always what I want to know. Because I actually want to know the validity of what's been counted in the real world, not necessarily validity compared to the input data set, which I know might not be perfect. That's why we are doing gridded estimates in the first place, because we don't have a very good data set of the population. And so one of the things that this, I think, coming in the future is doing a better job connecting people who are producing these gridded population data sets with folks like you all who are in the field doing real world enumerations of households, and closing that loop. You know, can we actually find a way to anonymize without sharing our exact cluster boundaries and stuff like this, but find a way to actually generate some accuracy statistics or validity statistics against existing gridded population models, and produce some of those results that we would need to assess what is a reasonable gridded population estimate. But then the next question is how accurate are the samples that we're getting? And as I was saying earlier, that even if you have an outdated census and you put that into a model, you might end up with some total counts that are still off, because the total counts are going to match the imperfect data that you put into your model. But you might get a more accurate distribution of the population in a gridded population data set, and therefore be able to draw a more accurate sample. Because as long as that distribution is pretty accurate, you know, the slum that evolved and the new development that occurred, if there's more people there that you were able to sample compared to, say, the old census itself, you'll end up with this better sample. And what I'll put it in the chat in just a minute, but one of our colleagues, Sarah Stevig-Ford, did a really fantastic real world study of survey accuracy using your Uruguay as a case study. So Uruguay had just had a census. It was widely trusted. And so they had a good census frame available. And so they did a large scale national opinion poll on this survey. It was an election opinion poll. And so they had the election results, they had the census-based sample, and then they had a gridded population sample. And they wanted to see which estimates got closer to the actual election results. And they found that their gridded population sample, of course, this is only one instance of a possible sample. There's theoretically infinite number of samples that could have been drawn, but in this particular case, the gridded population sample actually more accurately and more precisely predicted the election results than their census-based survey, which is to say that the gridded population estimate, which had not been based on the most recent census, it was actually the previous census, still did a good job at giving an accurate distribution of the population from which they sampled from. Dale, did you want to say anything else about the standard errors or margin of error?
No, those are just calculated in the standard way. So we have the sampling frame comes from a different source, but then estimating sampling variability is just as it would be from any other frame. I dropped the link to Sarah's publication in the chat. Yeah.
We have in reference to in Iraq, for example, where we've studied gridded samples a lot, we have official estimates every 2 years based on 50,000 person surveys. And so the statistics office does that up to a small PSU. Would that be considered as inaccurate?
That is an excellent question. I think there's a number of different techniques that one can use to estimate population distributions from these surveys that are done. And they might actually lead to pretty good estimates to sample from using existing methods. One of those methods would be doing some geospatial modeling, basically a gridded population model. It could be not necessarily in the grid cell units. The units could be census EAs, but you could be using that same geospatial model to find geospatial covariates that correlate with the populations that you did count, and then predict into areas where you didn't count and update those modeled estimates. So it's probably I know that one of the very first gridded population surveys ever conducted was in Iraq in 2010. And so I'm sure that the National Statistical Agency and folks in Iraq are actually quite skilled at some of these techniques and probably have great sample frames to draw from. And they might be using census boundaries instead of these grid cells, and that would be perfectly sensible.
Thank you. We have a question on the building footprint database. Could you clarify whether non-residential buildings are included in the database?
This is another area where there's a lot of changes happening rapidly. And so, I might not have the hottest off the press information, but just looking back to these different gridded population data products, they are using, all the more accurate ones, bottom right, are using building footprints in some way. And it's not always the same building footprint data sets. So building footprint data sets, sorry, can you repeat the question just so I don't go on a tangent? Sorry.
Yeah.
Does it include non-residential buildings? And the answer is yes.
Yes. So many of those gridded data sets are using just building footprints without classification. The one exception is Global Human Settlement POP2. They have a model that attempts to classify residential and non-residential buildings. And their model also includes building height. And then they classify this into a couple different bands of building height. And that data set is actually used to disaggregate population counts. And so they do not allocate population to buildings that in the model are classified as non-residential. So all of these data sets have maybe multiple models behind them that might contribute error. My finding of some of these building footprint data sets so far is the residential, non-residential classification is not perfect, but I really appreciate where that data set is going. And this GHS POP data set is being updated, and they have many different researchers working on this continuously. And this is being updated every 1 to 2 years into the future, up to 2030, at least at this point, but I think beyond. So I would expect that building footprint data set will improve rapidly with the models and technology available. And I wouldn't be surprised if some of the other building footprint data producers start following that kind of approach.
Oh, thank you. We have a couple of related questions here. I think in areas that are among the most challenging for any sort of survey, but the potential of using it for hard to reach populations such as refugees, displaced persons, and related to that, how accurate are the gridded population data with areas like refugee camps where most buildings might be tents?
This is a lot of folks are interested in using these population estimates for highly mobile populations, and it's not necessarily the best set of data to be using. So nomadic populations are not going to be very well represented with the current models and the current data inputs to those models. This is a rapidly changing field. Who knows, maybe these models will get better at identifying tents, but there's always going to be this lag of data production, like when the data were produced and the estimate it's for. Generally, I would not use a gridded population estimate to sample nomadic populations. There's going to be better approaches for that. I have seen this used very successfully for refugee settlements where population in Uganda, where populations are given. Uganda is a pretty unique migration and refugee policy where they designate areas for different refugee populations to settle. So it's basically like a village that is predominantly from a particular background, people who are refugees. In those cases, the World Pop peanut butter data set was used. This data set is actually just a building footprint model where you input the population counts. So they had a population count for whole settlements that came from UNHCR, I think, and then they used the building footprints to disaggregate that to little grid cells. And that combination worked really well in the Ugandan context. It does not work as well in, say, an urban setting where refugees live among the general population. You're just gonna run into challenges in basically slums and informal settlements, and migrants who are integrated with city populations are just a really challenging group to reach. And that's where I find the area microcensus designs are very attractive, because at the very least, in the interview stage, you can start to identify those hidden populations that might not be listed in official ways or being even reported during your listing activity.
Excellent, thanks. I'm going to go back to Arwa's question of multiple questions on the World Pop data with reference to Iraq, although other places. So the current World Pop is just showing huge oversamples, and we can see the number of grids per city, and it doesn't reflect the population of those cities. How do we work around that?
This is, so World Pop Unconstrained and Landscan Global have been the data sets that have been available the longest. And in Iraq, World Pop Constrained is also not going to look that different from World Pop Unconstrained. What this means is unconstrained means that every cell that's land-based will have an estimate. The vast open desert will have cells with 0.001 population per cell. So every cell has some estimate. Sometimes it's negligible. But that modeling approach tends to spread the population out, and it basically gives you overestimates in less dense areas, and it underestimates the highest density cells. This is why I've got a big caution symbol on it, because in Iraq in particular, that's not going to be a great data set to use. Constrained means that World Pop has basically masked out unsettled areas from a different model that classify settled and unsettled areas, and they're only going to estimate in the settled cells. That basically removes like the vast open desert, but it still does a lot of smoothing inside of those settlements. The only place where World Pop Constrained works really well is in African context, where they have a really great building footprint data set that they use as a predictor. The rest of the world, they don't have that data building footprint data available, and therefore it's not that much better than that unconstrained model itself. I'm just trying to think if I've got some recommendations for the Iraq context. Landscan, I find, can be really, Landscan there's a lot of manual adjustments that happen in the Landscan process. So, and it's produced by Oak Ridge National Laboratories as part of the US government. Where US government has a strong interest, they might have spent a lot of time doing these manual adjustments, and you might find some really useful estimates in Landscan HD or Landscan Global. There's some parts of the world where this is just really, really not accurate at all. It's possible, given the politics of the world, that the Landscan estimates in Iraq are decent. It's worth having a check at Landscan HD, which is a 100-meter product, and I do think they have an Iraq data set. And GHS POP 2 might have something useful. GHS POP and World POP are often compared to each other because World POP tends to overestimate rural areas and underestimate urban, and GHS POP tends to do the opposite. So there are people out there in the gridded population production world who say that if you combine a few of these and kind of take an average, that you can somehow get closer to the real population. And I think first, you need to know a lot about the different models, about which ones even make sense to average. And you probably want something a little bit more explainable to whoever's funding your survey. So I'm not sure if this would fly in the survey world, but if you were to take a few gridded population products, World POP and GHS POP 2, if you average those, possibly HRSL as well, you might find some value in the middle that's not an overestimate and is somehow closer to the reality. You could try it. It's a lot of work to do that.
Thank you. The micro census and comparisons to other models seems to be generating a lot of interest. We have a question sort of thinking about non-response. In classic two-stage sampling, you're doing several visits to non-response, to deal with non-response. What are the, and I guess maybe to generalize on this, what are some of the variants of this, or how do you think about one visit versus multiple visits versus, you know, do you ever do multiple visits in a microcensus?
Absolutely. So area microcensus can have the same protocol where you go back over, say, 3 consecutive days and do visits, or come back, you know, hit unit. This might be PSU 1, and you might do PSU 1, 2, and 3, and then come back and do 1, 2, and 3 again to get non-responders. So you can absolutely use that approach. The times when you might not do that is a conflict setting where you really are in and out of the field, and you just have a very high non-response rate if you're in an urban context and people are off at work and not findable.
Yeah, great. I wonder, maybe thinking a little more about possible uses in different types of studies we sometimes do. Sometimes we're interested in oversampling on some subcategory of people. We're trying to reach a rare population, so you basically told us if we're dealing with urban refugees, we're not going to have much luck doing that here. Are there cases where subgroup estimates are reasonable and feasible in these sorts of data sampling?
Absolutely. Maybe, I mean, Dale works a lot with vaccination coverage surveys, so maybe you want to jump in, Dale.
Sure. Yeah, oversampling is definitely possible. We need to have some sort of reference for the population that we do want to oversample, but there's no difference, I think, from a traditional multi-stage sampling design concerning whether we want to oversample a particular population. In vaccination coverage surveys, we're sometimes trying to oversample families that have children in a very narrow age window, and so we might increase the number of households that we're going to visit so that we can yield productive conversations with those types of families.
Great. Do we have any other questions here coming in from our many WAPOR members literally around the world? I've seen questions from Iraq, from Syria, from Argentina, from from all over. So thank you all very much. For the WAPOR members, I would just like to remind you that coming up in December 15th, Kieran Healy will be joining us to talk about data visualization. This is something that we've heard from WAPOR members that you would like to hear more about, and we're bringing in someone who has a lot of expertise in that area. And also for WAPOR members, you're getting your membership survey right about now. We are asking you for topics that you might like to see discussed, and are very interested in hearing what you have to say, and we'll try to respond to that. But I would just like to thank so very much Dana and Dale for this wonderful overview of gridded population surveys, something a lot of our members have experience with, and many more are extremely interested. So thank you so very much.
Great. Nice to be with you.
Thanks.
It was a pleasure. Thank you, Chase and all. Bye-bye.
Thanks.